Kira Van Winkle, and I'm a middle school science teacher in Iowa. If you're watching this video, it means that your class recently started a new unit, but you were absent for all or part of the first lesson. Before I begin walking you through this first lesson of this new unit, I'd like for you to gather a couple of supplies. You'll need your science notebook and a writing utensil. If you don't have your science notebook handy, you can just grab a few pieces of blank paper. There's going to be some opportunities for you and I to work through some of the activities and discussions that took place in your classroom while you were absent. I've included a link to the handouts and resources that we'll use for this lesson at the bottom of this page. If you need to access those, you can click now, or you can go gather your other supplies. Just pause the video and continue when you're ready to begin. Okay, so check this out. On this slide, I've shown you a tweet that I found from NPR that says that Mount Everest grew a couple of feet overnight. Have you ever heard of Mount Everest? What do you know about it? My husband likes to watch documentaries, and he was watching a documentary about Mount Everest recently, and it talked about something that this tweet also said, which is that Mount Everest is the world's highest mountain peak. So Mount Everest was already really, really tall, but now it's even taller. Like, take a minute, just stop and jot some ideas. Like, what do you think is causing this? And maybe not even just Mount Everest, maybe other mountains are growing too. What are some ideas that you have that could cause mountains to grow? Pause the video here while you jot down some ideas on a blank piece of paper. All right, so I was kind of unsure where Mount Everest was even located, so I've put this on a map, and I actually also placed where I'm located in Iowa. So you can see on this map that I have all the way over in North America, where Iowa is located, and then it looks like Mount Everest is actually located in Asia, and that's 7,600 miles between my location in Iowa and Mount Everest. Mount Everest is located in a country called Nepal on the continent of Asia, and it's right on the border of Nepal and then another country called China. So when you return to class, maybe see if your teacher and your classmates figured out how far from Mount Everest your school is, and see if they've added that to maybe a map in your classroom as well. All right, before we move on, I'd like for you to find a blank piece of paper and create a T-chart. So this can be in your notebook or just on a regular piece of paper. Make a T-chart that says notice and wonder. And we're going to do a little bit of reading about Mount Everest. And I'd like for you, as we read, to jot down some things that you notice and wonder. So take a second and add this T-chart to your notebook. And then at the bottom of this page or this slide, there is a bit.ly link to the reading. So I'm going to have that reading also shown on the next slide. But if you would like to have access to that outside of this video, you can see that on that link. Okay, so we've used this strategy before called the closed reading strategy. And it requires that you read text more than one time. We're going to read one time through the reading together. And as we read, I'll kind of pause and let you jot down some things that you notice and wonder. But it's going to be important that you go back and follow these instructions on this slide and read it kind of on your own a second time. So as you read, the closed reading strategy suggests that you identify questions you're trying to answer in the reading. And then also we're going to read once for understanding, and that's what we'll do together. And then a second time to highlight a few key ideas that help answer the questions you had. You're going to summarize the key ideas in your own words or in diagrams or in both, and then jot down new questions that this raises for you. So we'll kind of cover a little bit of this as we read the first time through, but it's going to be important that you read that article one more time on your own. Again, there's a bit.ly link at the bottom of this slide that can help you access this handout. All right, so let's read through the reading one time together. And then as we go through, I'm going to pause at the end of each paragraph and have you jot down some things that you notice and wonder from that paragraph. Okay. All right, so the title of our article is called What is Happening on Mount Everest? Mount Everest is the tallest recorded mountain in the world. It's located on the border of two countries, China and Nepal. In the past, these two countries have collected earthquake, elevation, and location data separately on their own sides of the mountain, but they had not compared the data with each other to check for accuracy. Since each country was collecting separate data and not using the other country's data to check their work, this led to a disagreement on the exact height of Mount Everest. In 2015, a massive 7.8 magnitude earthquake occurred near Mount Everest. Areas surrounding Mount Everest and in both countries felt the earthquake. Scientists believe that the earthquake may have impacted the height or elevation of the mountain. These two countries decided to share their GPS data to figure out if there were any changes to Mount Everest due to the earthquake. Okay, I'm going to pause for a second and have you write down your notices and wonders from that first paragraph. Okay, next paragraph. In the years that followed, Chinese and Nepalese scientists set up a global positioning system, or GPS receivers, at different places on the mountain. GPS provides the signals that our cell phones use to determine where we are located on Earth and can provide us directions to get to a new location. The GPS sensors that were used on Mount Everest are even more sensitive than those that are in our phones, which enable them to detect a change in position as small as 1 millimeter. I'll pause again and have you record your notices and wonders. Okay, last paragraph. The first official measurement of Mount Everest was reported in 1856. At the time, its peak was recognized to be about 29,002 feet above sea level. But since then, GPS data sharing between the two countries has allowed scientists to determine that Mount Everest has increased in elevation by an average of 0.79 inches or 2 centimeters each year. In 2021, its peak was at 29,032 feet above sea level. In addition to these changes in height, this GPS data has also provided evidence that the peak of Mount Everest is moving at an average of 1.6 inches or 4 centimeters every year to the northeast. All right, take one more minute and jot down your notices and wonders from this last paragraph. Okay. Let's take a minute to look at this example of another class's notices and wonderings that were shared out. The ideas on this poster paper may be helpful to you to refer to when you develop your initial model later in the lesson. So some of the things that maybe they noticed were that Mount Everest has been recorded as 30 feet taller today than it was in 1856, and that it moves 4 centimeters on average every year to the northeast. It increases in elevation about 2 centimeters on average a year. There's an earthquake that happened at Mount Everest. Then we're kind of wondering, like, how can an earthquake cause this thing to happen? And then we're looking at, did the growth rate per year change after the earthquake? Why is Everest moving to the northeast? How come it's not south or just east? And then how do they measure the height or distance? Like what technology do they use? Sensors? How is it that these GPS things work? Can they use satellite data? And then how accurate is the data? And then could this be caused by tectonic plates shifting? And then is this an average? Like, is some years it gets taller and some years it's not quite as tall? And then does the location between the countries affect the height? And are there other mountains in the world, so either in the US or internationally, that are growing and or moving? So let's go back to our initial stop and jot from the beginning of this lesson. So now that we've read through the handout about what's happening on Mount Everest, we need to brainstorm some ideas for two questions instead of just one. So let's think about these questions. What are the possible causes for the increase in elevation of Mount Everest? And so that means like moving upward. And then what are some possible causes for Mount Everest moving northeast? So why is there sideways movement? So take a minute and jot down more ideas about what might be causing these two different shifts in Mount Everest. Pause here if you need more time and then press play when you're ready to move on. Okay, so on this slide, I have a handout linked on this bit.ly link that's called Explain How Mount Everest Moves and Grows. Okay, so we're going to take a few minutes to develop a model representing what we think could be causing these changes to Mount Everest. So first of all, what do we know is happening to Everest? We know that Mount Everest is moving about 4 centimeters to the northeast every year, and that it's growing taller about 2 centimeters every year. So as you develop your model, think about where Mount Everest is located. So maybe like seen from a bird's eye view, so from above, like on a map. And then think about Mount Everest, the mountain. So as you develop your model of what could be causing the tallest mountain to grow and to move, it might be helpful to think about like not only where the mountain is located, but also what the area around the mountain looks like from above, and then also maybe from the side. So there maybe could be some things under the mountain that are causing it to move, or there might be things to the side of the mountain, or maybe it has to do with what the mountain's made of, or maybe where it's located. So take a few minutes and develop an initial model that represents your ideas for what's causing it to increase in elevation, so height, and then also what's causing it to move sideways, northeast, 4 centimeters per year. So you can either access this handout using the bit.ly link provided, or you can create a handwritten copy in your notebook. Either is fine. Just pause the video here while you're developing your model, and we will move on when you're ready to begin. Okay, so this slide shows an example of a class consensus model. So once your class developed their initial models, they probably had a conversation and said, here's the things that we agree on and maybe the things that we have questions about. So this model is probably different than what your class came up with. So make sure when you get back to class that you look at your class's consensus model and see what they came up with while you were gone. I'd like for you to take a few minutes to observe this model and figure out like in what ways is this model of the changes to Mount Everest similar to what you made? How is this model different? And then I'd like you to create a T-chart in your notebook and record those similarities and differences. So in your notebook, make a T-chart with the word similarities on the left and differences on the right. And then I would like for you to examine the slide and your model and see what it has in common and what might be different. And then just pause the video here while you do that and press play when you're ready to continue. All right, so now that we've looked at this initial model and the consensus model, we're going to pause for the day. We're going to begin day 2 by considering other mountains around the world. That was one thing that my students were really curious about, and me in particular. I just wonder if this is happening only to Mount Everest, or is there other stuff happening around the world? So if you only missed day 1 of this lesson, you can stop the video here. Make sure you share your notes and your model with your teacher and your classmates when you get back. If you missed the second day of this lesson, you can go ahead and continue watching the video. All right, so let's begin day 2 of our first lesson. You're going to need the same materials as were needed on day 1, which were your science notebook or several blank pieces of paper, along with a writing utensil like a pencil or a pen. And then there's also going to be some helpful resources shared in day 2 that you can access using the bit.ly link here on this slide as well. Take a second and gather your materials. If you need to press pause, go ahead. Okay. Yesterday, we noticed some interesting things that were happening to Mount Everest, which is a mountain found in Asia. But what about other mountains? There are a lot of mountains on Earth, and Mount Everest is only one of them, even though it's the tallest one. So what do you think we might see at other mountain peaks and other mountain ranges? Take a look at the questions on this slide. Jot down your thoughts in a new space in your notebook. So what are some other mountain ranges or mountains that you know about? And do you think that they are changing in similar ways to what we read about yesterday with Mount Everest? And do you think investigating other mountains might help us figure out what's happening at Mount Everest? So jot down some ideas in your notebook. Okay. So what I would like you to do is set up a new data table in your notebook that looks like the one on this slide. So write a heading at the top of your paper that says mountain case sites. And then we're going to want 3 columns below that, with the left column heading reading types of data, the middle column reading data, and the right column's heading should say how this data connects to to mountains changing. So pause the video here if you need some time to create this chart. The goal of data analysis is to look for patterns in any changes in height or movement, as well as any ideas about possible causes for these changes. So when I did this lesson with my class, some of the data that they thought would be important in helping us figure out what's happening to Mount Everest was information like the height of the mountain, whether there was movement from the mountain, and then how much change there has been. And then where's the mountain located? And then because of that earthquake around Mount Everest, we also thought maybe earthquake activity data would also be an important thing in helping figure out what's going on. So we're going to spend a little bit of time now looking over some mountain information cards. The cards will probably have more information than just whether the mountains are changing. So if you see something else on these cards that you think might also help explain what's happening at Mount Everest, add a row to your data table called Other, and you can include that in the data. So this is just the example of the data table that my class made. So you can see that it's got different categories. So height of the mountain, movement of the mountain, changes in height, earthquake activity. And then we also added other data. We weren't sure what we were going to find on these cards. There's a link on the slide for the mountain cards that you will need to access. We're going to go over a couple of them together, but you also may want to look at those on your own as well. The handout that is linked here includes information about 5 different mountain ranges. And the first one is a little bit more information about the Himalayas, where Mount Everest is located. So Mount Everest is just one mountain that's part of a mountain range called the Himalayas. So let's analyze the data card about the Himalayas to look for any other data that could help us figure out more about Everest and why it's changing. So just take a minute to look over the information on this card. I'm going to give you some time to read, but if you need more time, go ahead and pause the video until you're ready to continue. So as a reminder, this handout is available using the bit.ly link that's on this slide. Okay, so after reading that card, what do you think we should add to our data table that seems important for helping us figure out more about this Mount Everest phenomenon? Here's an example of what my class thought should be included. So we have information about how high the mountain is, how it's moving, how much it has changed, whether there's earthquake activity. So it turns out there's a lot of large earthquake activity here. And then we also added a little bit of other data. So go ahead and add what you think is important to your data. You can copy this or you can just jot down your own ideas. But if you need to pause the video here and add to your data table, go ahead. So this next part in class was done as a group. So your classmates had some time to work together to analyze information about the 5 mountain ranges and the case cards. Since you're not in a group though, we're just going to analyze one of the mountain case cards together. So we're going to look at the card about Mount Aconcagua in the Andes Mountains. But be sure to think about the questions shown on this slide. So is this mountain changing elevation or is it changing location? Why might it be changing? And then what patterns do you notice between Mount Everest and this new mountain, Mount Aconcagua? So here's the case card for Mount Aconcagua, which is the mountain found in South America, found in a country called Chile. So there's a lot of information to sort through here. So it might be helpful to just focus on finding information that can help us explain the changes in elevation or sideways movement of the mountains. So I'm going to give you a minute or two to look over the data on this card, and then go ahead and add some data to your data table as you read over. If I don't give you enough time to look things over, feel free to pause the video at any time. Okay, I'm going to move on to the next slide. So this is the data table, again, from my class, and we have added some information kind of in that like fuchsia color about Mount Aconcagua. So do you agree with the information that's shown on this data table? So if you're looking at your data table compared to ours, maybe like place a little check mark next to information that both you and this class added to your list. So this class added that Mount Aconcagua is 22,838 feet tall. It has the tallest active volcano in the Andes Mountains. It moves 2 centimeters per year to the north, and it seems to be experiencing something they call growth spurts, which means that it's growing 10 millimeters every 10 years. And that earthquakes happen here a lot, and there's a lot of different climates. It's about the same age as the Himalayas. So the Andes Mountains are about the same age as the Himalayas. And also, like the Himalayas, there are glaciers that are found in some areas of the Andes Mountain range. And then some ideas about causes from this class are that maybe the volcanic activity or the large range of climates could have some impact on the growth and movement changes of the Andes Mountains, specifically Mount Aconcagua. So at the end of day 2 of this first lesson, there's a discussion in class in which students are sharing out patterns that they notice in each of the mountain case cards. So I'm going to show you our completed data table from my class. And then I would like for you to take a look at the handout. So the handout's shown here. This is handout 4, patterns of change. So if you were to use this bit.ly link to access the handout, you're going to be looking for handout 4. So if you don't access this one, if you could please just copy down this data table into your notebook. Okay. I'm going to have you pause the video here if you need more time to copy this data chart or to access this handout before we move on and look at the completed data table. Okay. So let's take a look and have you look at this class's data table and write down any patterns that you notice between the mountain cases. And have you write that on your patterns of change data table. So what are some patterns of change that you notice between the different mountains? Make sure you jot those ideas down in the bottom box of your patterns table. And then what other patterns did you notice in the data about causes and growth of a mountain? That's going to go in the top left box of your patterns table. And then what patterns are in the data about causes of shrinking or decreases in height of a mountain? It turns out not all of these mountains are growing. And so what do we think could be causing that shrinking or decrease in height of a mountain? And you're going to put that in the top right box of your patterns table. So go ahead and pause the video here. Take a look at this data table, or you could look at the handouts if you'd like, but go ahead and look for patterns between these mountains and mountain ranges and record that into this patterns of change data. Go ahead and pause and then press play when you're ready to continue. Okay, so we've now concluded day 2 of lesson 1. When you return to class, you're going to notice that the mountains from the mountain case cards are going to be added to that world map like we saw on day 1. So be sure to look at the patterns that your classmates noticed, and then maybe seeing them on the map is also going to be helpful in identifying some causes of those changes. If you only missed this part of the lesson, you can stop the video here. If you missed the 3rd day of the lesson in class, you can go ahead and continue watching the video. Okay, we can now begin day 3 of the first lesson of this new unit. If you have it available, go ahead and get out your model diagram from day 1 and your mountain case card data table and patterns sheets from day 2. And you're still going to need a couple of pieces of paper or new pages in your notebook and a writing utensil. If you need to pause while you gather those supplies, go ahead and do that now. Okay, so take a look at the handout pictured here on this slide. So we've developed a model for a mountain that's growing. But now we have found out that some mountains are shrinking. So let's think back to what we have shown that could be causing our mountains to grow. Do we also think that these things could be causing our mountains to shrink, or could it be something else? Take a few minutes, develop a model to represent what is causing a mountain to shrink. So you can either copy this handout into your notebook and handwrite it, or you can access the handout using the link provided on this slide. This is handout 5 for this lesson. So pause the video here and complete your model, and just press play when you're ready to continue. Okay, so this is another class's revised consensus model that now includes information about what might be causing mountains to grow, move, and now also shrink, like Mount Mitchell. So are there any ideas from your model that you can see on this example? So I'm seeing things about like precipitation, and there's stuff about water. So I'm wondering if maybe that's part of your model as well. If you see anything that's similar to your model that's on this slide, go ahead and just place a check mark on your model so that we can kind of make sure that we're seeing some similarities, maybe even some differences between the two models. Okay, so I'd like for you to turn to a new blank page in your notebook or just on a blank piece of paper, and I'd like for you to create a title that says related phenomena. So for this part of the lesson, we'll make another T-chart. The left side of the T-chart should say examples, and the right side should say causes. And I'd like for you to think back on all of your experiences in your life where you've noticed maybe a change in the surface of the land, or landforms such as hills or mountains, shorelines, or other features on Earth's surface. This could even include things like roads. So these changes could be over a very short period of time or a long period of time, and or they could be big or small changes to the land. So if you can't think of anything that happened where you live, but you can think of a change that you saw happen somewhere else that you visited or that you've read about, that's fine too. Just take a couple minutes and record all of the related phenomena that you can think of in your notebook, and what you think the causes of these changes might be. I'm going to have you pause the video here while you record your related phenomena examples and causes. All right, so here's an example from another class. Take a look at this example of their related phenomena, and put a star or asterisk next to the examples or causes that maybe are similar to those on your list. And then if maybe this jogs a memory, you can definitely add more to your related phenomena as well. So on this example, we're seeing that they're talking about erosion of rocks, like near the coast or along beaches. And the cause of that, they're thinking, is the waves. So maybe the water hitting them. They're talking about how a giant pile of snow gets smaller over time. We used to have a big pile of snow pushed right up into our yard when I was little. And it took a really long time for it to get smaller. But I think, similarly to what this class is thinking, that maybe the sunlight had something to do with it. So the sunlight hit the snow and caused it to melt. They also mentioned maybe roads or bridges collapsing, and that could be caused by earthquakes. Some students went skiing, and they said that skiing hills actually get steeper, and they think it's because people are skiing over and over on that same hill. There's ideas about valleys getting deeper, and so maybe that's because of rivers running through it, and maybe some of the soil or rock gets taken with it. They're talking about rocks breaking into pieces in a creek, and maybe that's due to water pressure. Changing land at the bottom of a mountain, caused by rocks or mudslides from wind or rain. And then flooding makes rivers and roads, and that's because there's a lot of rain, and it's a lot in a short period of time, so very quickly. So again, place a star or asterisk next to examples or causes that showed up on your related phenomena table as well. And then if you need to, go ahead and pause the video while you complete that part of the lesson. Okay, so we've seen related phenomena. Now I'd like you to create a new section in your notebook that says new questions at the top. So now that we've looked at multiple mountains and the potential causes of those changes in either the location or the elevation of those mountains, I want you to write down some questions that you have that we could maybe investigate to help us figure out the phenomena that we've seen of these mountains changing. You're going to need to be ready to share those with your class and your teacher when you get back, but go ahead and just jot down a list of questions that you have that we could investigate to figure out this phenomenon. Okay, once you've finished your list of questions, you have finished day 3 of this first lesson. There's 1 day left. So if you only missed this part of the lesson, you can go ahead and stop the video here. If you still need to experience the last day of the lesson, you can continue watching the video now. Just make sure that you bring your questions with you to class when you return. All right, we're now beginning the 4th and last day of lesson 1 for this new unit. So if you have it available, please get out your model diagram from day 1. So about the movement and elevation changes in Mount Everest. And then your patterns data from day 2 and your explaining other mountains model from day 3, so the shrinking mountains. You're still going to need a couple pieces of paper or new pages in your notebook. You're also going to need a writing utensil. And if you need to access the handouts, the link is located on this slide as well. Okay, before you finished day 3's part of this lesson, you were asked to record questions that you have about the phenomena that we've encountered so far. So about mountains changing in elevation, either growing or shrinking, and then also their location is changing. And then we also created those extra phenomena about other landforms as well. So today, we're going to add to our questions in anticipation of adding questions to your class's driving questions board when you return. So we're also going to think about how we could investigate these questions in order to figure out what's causing Mount Everest and other mountains to grow or shrink or move. So take out the questions you wrote on day 3, go through your questions and see if you have questions on your list that address any of the following ideas. Okay, so do you have questions on your list that address movement of the mountains? Do you have questions that address the elevation changes, either growing or shrinking? Do you have questions about the area around the mountain, so above it, below it, near it? And then do you have questions about other related phenomena that you listed? So what I would like you to do is add or revise, so kind of change them up a little bit, at least 2 questions in your notebook. So you can use some of the question starters shown on this slide if you need a starting point. You can also use your notices and wonders, your initial models, your related phenomena notes to help you develop your questions. So pause here, add or revise at least 2 questions that are on your list from day 3. Pause the video here and then press play when you're ready to continue. Okay, so sometimes when scientists are trying to decide on their next steps, they need to look back at their questions and figure out like what data or information they still need. So let's do that now. So create a new section in your notebook titled Investigation Ideas, and then in parentheses, write information or data that we need. And it's just as it's shown on this slide. If you have room, you could create the section below the questions that you asked earlier, or you can create a new section. So take a few minutes and go through the questions you wrote. And as you look them over, think about things you could do in your class to help you figure out the answer to your questions. So go question by question. How can I figure this out? Is there specific data that you need? Would a simulation be helpful? Think through your questions and identify your ideas for investigation in your notebook. Pause the video here until you're ready to continue. So when you have your list finished, think about what you think might be the best things to start with as we move forward. And whatever you wrote down that you think is the best to start with, go ahead and put a star next to that. So you may have like one idea or a couple ideas that could help kind of jumpstart us into the next lesson. So again, create your ideas for investigation for each of your questions that you wrote. And then pause the video here while you work on that, and then press play when you're ready to continue. All right. Now that you have finished your list of ideas for investigation, you are finished with lesson 1. So your teacher will have gathered questions and ideas for investigation from your classmates. But those ideas that you bring to class are going to be really important and helpful in figuring out what's happening with these mountains. So be sure that when you get back, you share your ideas and your model with your teacher when you return to class.